In this video, we are looking at how to recognize covalent or molecular compounds. If a compound contains two or more nonmetals chemically bonded together, we can say it's a covalent or molecular compound. This occurs because all nonmetals contain many valence electrons and therefore can form a bond by sharing their valence electrons with each other to achieve a full valence energy level. We can see chlorine gas on the right, how their electrons are being shared. So you'll see I've circled up the pair that they are sharing, and because they share that pair, they now both have a full valence energy level. We're going to skip down to this part right here. It says circle the covalent compounds. So we are looking amongst all these compounds given, we are looking for ones that have two nonmetals. If we see a metal, we know it's ionic. We must have two nonmetals. So for potassium and oxygen, we see that in the periodic table, potassium is in column 1. It's a metal, so that means this is not a covalent compound. Carbon and oxygen, they are both to the right of the staircase. They are both nonmetals, so that means that is a covalent compound. Silicon and oxygen, silicon is to the right of the staircase, and so is oxygen, so they are both nonmetals, and this is a covalent compound. Hydrogen and chlorine, hydrogen acts like a nonmetal, so we pretend it is when it's bonding. So hydrogen is a nonmetal, chlorine is in column 7, it is a nonmetal. This is a covalent compound. Hydrogen gas is bonded to itself, so that's two nonmetals, so it is a covalent compound. Copper to chloride, so copper chloride, so copper is a metal. It's found in the transition metals in the middle. We can see it here, it's number 29. And we know that chlorine is in column 7, it's a nonmetal. So this is not a covalent compound because we have a metal. And then we have Bn. So B is boron, it's number 5, and nitrogen, which is number 7. They are both to the right of the staircase, so they are both nonmetals. That makes that a covalent compound. We are going to draw the covalent compound for hydrogen and fluorine. We've done this before, but we want to make sure we remember how to draw it. So hydrogen has one valence electron, where we have fluorine that is in column 7 and it has 7. So I've already put 1, 2, 3, 4, 5, 6, 7. So if fluorine shares this one with hydrogen, then hydrogen needs to share its one with fluorine. Now, also a special case, hydrogen only has one electron, so that means it only has one energy level, which means it only needs 2 to have a full valence energy level. So if we circle up the electrons, we say fluorine has these electrons, and we say hydrogen has these electrons, and then we have to make sure, we have to make sure that they have the right number of electrons in their circle to make sure that they have a full valence energy level. So for hydrogen, it has in its green circle, it has 2, so it is satisfied. Its first energy level is its valence energy level, so it's full. And then in fluorine's circle, we see 1, 2, 3, 4, 5, 6, 7, 8. So fluorine has 8 in its valence energy level. It is satisfied. That is our covalent bond. Okay, so now we are going to name our covalent compounds. The rules for naming covalent compounds are similar to ionic. However, since there are many different combinations for the same elements to bond in covalent bonding, prefixes are used to specify the number of atoms of each element. So you don't need to memorize these, they will always be provided to you. So when you have one atom, you say mono, di is for 2, tri is for 3, tetra is for 4, 5 is for penta, and hexa is 6 atoms. How do we name them? So we will always say the prefix first, and then the first nonmetal name, then another prefix, and the second nonmetal name with "ide" at the end. So for example, N2S4, there are 2 nitrogens, so we say di, and then we say the first nonmetal name, nitrogen. So dinitrogen. And then we look, and sulfur has 4. 4's prefix is tetra. We can see it here. So that makes that tetra, and the element is sulfur, so we start with the root, which is sulf, so SULF, and then we have ide at the end, so tetrasulfide. So N2S4, its chemical name is dinitrogen tetrasulfide. We are going to write the names for the following compounds. Pretend you didn't see those. All right, so we have P3O. So we have our first element, which has 3, so it's tri. Our first nonmetal is phosphorus, so tri-phosphorus. Our second element is oxygen, and there's only 1, so we have mono. And oxygen is ox, and the ending is ide. So this P3O is triphosphorus monoxide. Si3, so that's sulfur and iodine. So we say the first one's sulfur. Now the rule here is if we're describing the first nonmetal, we don't use the prefix mono. So we just say sulfur. And then we have 3 iodines, so we have tri, and it's iodide. CO2, there's 1 carbon, it's the first one, so we just say carbon, we don't need a mono. Our second element is oxygen, and there's 2, so we say di, and our ending is ox with ide at the end. So that is carbon dioxide. Our last one is N2O5, so we have di because there's 2. Our first element is nitrogen, so dinitrogen. Our second element is oxygen, and there's 5. The prefix for 5 is penta, so penta. And because it's oxygen, we have ox, so pentox, and ide at the end. So N2O5 is dinitrogen pentoxide. Since the same nonmetals can bond in different combinations depending on the number of electrons being shared, it can be difficult to predict the chemical formula solely from the elements. You will be provided with the chemical name to decipher the formula of the molecule or vice versa if the chemical name is required. So the formula for carbon dioxide, we see carbon, so we know there's only 1, so we say C. We see di, and we know it's oxide, and oxide is oxygen. And it's di, so there's 2 oxygen. The next one is dihydrogen, so we know it's hydrogen is our element with a 2 because there's 2 hydrogen. And dioxide is O2 because there's 2 oxygens. Oxygen gas is one of those diatomic molecules we had. So we had those Hofbrinkel ones we labeled on our periodic tables. So oxygen gas is O2. That's a special case. If you don't know the formula, drawing the Lewis dot diagrams can help you determine how atoms might combine to form a compound. So the chemical name for H2O is dihydrogen monoxide. That's because I have 2 hydrogens and 1 oxygen, so I have di for 2. Hydrogen is my element. Mono is for the 1 oxygen that I have, and oxide is the ending. The next one I have is NH3. So NH3 is nitrogen. Because there's only 1, I don't have to say mono at the start. And then I have 3 hydrogens, so it's trihydride. And then the last one is one of those diatomic molecules, one of the Hofbrinkels, so that is just hydrogen gas. So what you're going to have to do on the next page is you are going to have to practice determining the chemical formula, the chemical name, and if you possibly can do the drawing, the Lewis dot diagram drawing for a series of covalent compounds.